Hi guys, I would like to show you some feature how you could improve reinforcement learning algorithm. This is a Jupyter notebook with file, monitoring, agent. So we need to set our working directory. Next we need to import a library. So we could use several model like A2C or PPO, for example. And for environment, for training environment, we could import gym and Retraining. Next one, we need to use base callback. It would be important for us. And monitoring, it means we should to save the best model for our reinforcement learning algorithm. So let's do it and we do some review. For example, I would like to download data for the last 3 months, 5 minutes bars. Next, we do the same. We need rename some columns. It would be open hello plus volume data, and we should for this environment should be column name start with upper letter like this one, data open. Okay, and next one we need to create some environment. It would be we have multiply types to create environment. For example, in the previous I show you how to create environment for multiprocessing, and in this one you should indicate that phi would be 0. It would be for train, because we need to find some relationship. And next one, if we make sure it's working, we could do this algorithm more complex and increase some fee or something unusual spend. Okay, so we need to create class. It would be save on best training reward callback. It means we should save the best model, because when you run your reinforcement learning algorithm, sometimes we have overfitting. For example, after 100 epoch, you achieve the best model, but after the 500 epoch it would be not working and the result would be worse. So we need to find some model what would be the best for us. So this is some patterns and you could use it. So we used a base callback class what we import from this library, and you see. Next one, we need to define the folder when we are going to save our model. It will be here, and you see we calculate mean reward if our mean reward would be more than the best mean reward what we said before, and it means we should to save this model. This is some simple callback function. Okay, and next one, let's do, we define this working directory. You see, for example, I used tmp folder, and I'm going to save this data here. Next one, we need to create some plot to understand it's working or not. It would be maybe some more clarify for us how it's working. So let's do it. And the first one, we need to create environment, and next for display some data and monitoring this process, we should use monitoring class. And you see the wrapper for gym environments. And next one, we create this class and we check frequency each 1000 times, and we input our log dir. Next one, we input number of our timestamp. For example, in this case, you could increase, for example, 3 or 6. It means 10,000 or or 100,000 timestamp, and you could use it and change something, these parameters. But when you change it, and it means a total timestamp, if it would be the too many big, well, it means this process to learning, it takes maybe 1 day, for example. In this case, when I run this callback function, it takes for me maybe 1 hour. So when I wait, and you see, for example, when we have some the first steps, last minute reward was with negative value, but and the latest timestamp we achieve some positive last minute reward for episode, and it means we could achieve some results. But you see, we have some unstable dynamics to improve our reward. For example, this one we increase reward, next one is decrease, but this point would be the most profitable for us, and we save this model here. But you should be careful, understand if you have some too long time for timestamp, it means you haven't guaranteed to achieve the best model. You see, after the best reward, we achieve the worst reward. It happens sometimes. But for reinforcement learning algorithm, it's very important. It's tuning our model and find some best hyperparameters and create some the best model, and we could use this is the best model for our goal. Okay, so next one, for example, we could load this data. For example, I did it 1 week ago, and we could test how it's working on the new data set, but I would like to show you what was on the 1 week ago when I run this repeater notebook. And you see, for example, we're going to display our data. It means some trading point where is okay. So we define observation like environment, and we do reset. Next we run while loop, and we create our point when we have some trading. For example, you see sometimes we have short signal, but mostly we have a signal for green. But I see, for example, this peak was red signal, also red. It's very interesting. And what is mean? This is some total reward for this time range, and we have total profit, and we generate 25% profit. Next, for example, we could use more details report with this profit, and you see where is our cumulative returns. This is about 26%, and let's look at the drawdown. It's about 12%. Okay, longest day for drawdown, it was about 1 month. Okay, I should improve it, and this is some table with this drawdown, and we have some big drawdown period for our strategy, and you should increase this one. But in general, we find some relationship, and it means our algorithm could find some relationship on the market to make profit. But let's, for example, test this data on the new data set. For example, this model was about one week ago. Let's look on the folder when I save this model. Yeah, it was 1 week ago. in Sunday, previous Sunday. Today is Saturday. Okay, let's look in. We need this best model. Okay, next one I would like to create callback. So we downloaded data from Binance. Next, let's create environment. We did it. Next, we need to create path to our model, but we should missed this one because I wouldn't like to run this again because it takes multiple times. I would like to load this data again. Let's look in and let's do testing. Environment is not defined, so I should to create environment without train. So let's do this one. I should create environment. Let's look in with this environment. Okay, and let's do it here. We import our environment. Okay, and next one we're going to use this model and test how it's working. It will be profitable or not, I don't know. We should check it. Take some time to display this data. Okay, total profit, and it looks like profitable, but we should run it again because we have a stochastic problem here, and if you run it again it could be result is simply different, and we should to test it several times with this model. Okay, let's look in again. I need to find what would be the results. Okay, 23%, and let's look in on the total profit, and would like to see what happens in the last week when we not train this model. Okay, and you see it's not working. Very nice, very nice. And it means we should retrain this model every time. And let's look in, for example, on the, let's create the new model A2C, for example. It would be what we need to do. We need change these parameters. A2C actor critic model would be working faster. Let's, for demonstration, decrease number of timestamp. Let's look in. Maybe it takes some minutes. Let's wait. Okay, guys, it takes 5 minutes to learn. Let's do also testing. Okay, we need to find what would be the reward on our data set. Okay, and in this case we haven't enough profit, and you see we couldn't achieve some results because it takes small time to learn this model. And let's what we need to do. For example, let's increase let's change PPO model, and let's do, for example, check frequency every 10,000 step, and let's run it again, and let's find what happens. I would like also to change number of window size. Maybe let's create small. Let's do 15, for example. Yeah. Okay. And I would like to train it again. So let's wait. Okay, guys, we finished to train, and let's save this model again. I would like to load this model again and test it on our data set. Let's look in. Load this model, and let's check updating the data. Okay, it was update. Okay, we create environment, and let's create this plot. I run it, this model, and let's look in pandas. And you see we have some results, but I need to test it again. I'll load data. Okay, guys, we finished to train, and let's save this model again. I would like to load this model again and test it on our data set. Let's look in. Load this model, and let's check updating the data. Okay, it was update. Okay, we create environment, and let's create this plot. Okay, so we achieve some results. 15%. Oh, sorry, it's not correct. I need to run it again. Why it's not working? Indexes. Okay, let's look again. Because I run it, this model, and let's look in pandas. And you see we have some results, but I need to test it again. I'll load data, create environment, render the data from environment. Let's look at the results. 3%, but reinforced learning algorithm has a negative reward. We need to improve these results. Let's achieve these results. Okay, so let's increase window size, for example, 100. Let's do 500. It would be a big window. Let's create environment, and I would like to run it again. So let's wait, guys. So guys, it takes some time. Yes, it was about 30 minutes, and you see we have some noise of rewards of multiply epochs, means timestamps, and we saved the best model. But in general, we should change the situation because it's not good. For ideal moment, when we increase number of timestamp, our reward function should be increased, but in this case we have some random noises. But we saved some model. Let's look in on this one. We should load the best model. Next one, we should create environment, and let's do it again. Render our rewards. When we predict in this while loop, we predict action and state and calculate a reward. Okay, but you see we have total profit is about 55%, and let's look at some breakpoint because we should find that short is also created. Yes, for example, like this one, short point, and short point. Looking not bad. Okay, you see cumulative returns is 55%, and let's look in drawdown. Okay, it's 11%, and drawdown day also 27 days, not good. But in general, cumulative returns looks not bad, but we should increase these results. So guys, you could use this approach to create callback function to save the best model when you run, multiply when you run on the long time with timestamp, and you save the best model, and you could then you could use this best model for your trading. In the next, we continue to deep in reinforced learning problem. And if you like this video, subscribe to my YouTube channel, and see you next time. Bye.